All right, welcome. So today we're going to be talking about chain rule. Now, chain rule is one of the harder differentiation rules to master in calculus. If you're watching this video, I'm going to have the expectation that you understand differentiating polynomials, natural logs, exponentials, product rule, and quotient rule, and so on and so forth. So please keep that in mind, but all at a basic level. The definition of chain rule is as follows. D of dx of g, or of f of g of x is equal to f prime of g of x multiplied by g prime of x. All right, so what does this mean? I know this probably looks pretty confusing. So you've probably seen it before, but d of dx just means the derivative in terms of x. This isn't too important to understand until we get into implicit differentiation or related rates of change. As for the definition, so if we take the derivative of a function of another function, the result is the derivative of the outside function with the inside function remaining the same, all multiplied by the derivative of the inside function. So to make this make sense, I'll give you an example. We'll call f of x x squared, and we'll call g of x sine of x. So for this example, we know that f prime of x would be 2x, and that g prime of x would be cosine of x. Now, if you don't already know this, then this is not the video for you. But traditionally, if you're at this point, you would know how to differentiate both of these things. Now, to apply it to chain rule is, what if we had a function that said sine of x squared? Well, to take the derivative, we would do the derivative of the outside. So treating the inside, the sine of x, as if it's just x. So we'd bring down the 2 like we do in power rule, leaving the inside the same, and then multiply the outside by the derivative of the inside, which would be cosine of x. And that would be our answer. So the way I like to think of it is outside, inside. And you'll see it later in the video that chain rule can get big and it can get messy. But the general rule is you do the derivative of the outside while keeping the inside the same. So we brought down our 2, kept it as sine. Then you multiply it by the derivative of the inside. So let's try a few more examples. So say we had the natural log of 5x minus 2, right? So we know that typically the derivative of a natural log of x would end up 1 over x. So in this case, we would do the same thing. So we'd have 1 over, this is for f prime of x, 1 over 5x minus 2. So the derivative of the outside, keeping the inside the same, then multiplied by the derivative of the inside. Now the derivative of the inside would just be 5. So your final answer would be 5 over 5x minus 2. Easy enough. Now additionally, let's try e to the 5x. Right. Now typically the derivative of e to the x is simply e to the x. Now in this case, we treat it the same. So the derivative would start out with just being e to the 5x. That's the outside, while keeping the inside the same, and then multiply by the derivative of the inside, so multiplied by 5. And we have 5 e to the 5x. Now excuse me clearing my throat, I'm pretty sick. So that would be this derivative. Now I like to think, when talking about the original definition of chain rule, like I did at the beginning, I like to think of these things more as transformations. You know, e is a transformation of x, and in this case it's a transformation of 5x. So if there's a transformation transformation being done to anything other than just x, you're going to have to implement chain rule. Now, ironically, you're actually doing chain rule with your regular derivative definitions. We'll use sine of x as an example. Okay, if we take the derivative of sine of x, we'll treat it the way we do chain rule, right? Derivative of the outside, so it ends up cosine of x times the derivative of the inside, which would just be 1. So that's why you never see chain rule manifest in our traditional differentiation rules. But when we have anything other than just x being transformed by some sort of algebraic function or trigonomic function, then we're going to have to do chain rule. Now, the last simple example I'll do is cosine of 6x. Now we're going to start with the outside. So the derivative of the outside while keeping the inside the same, so negative sine of 6x, multiplied by the derivative of the inside, so by 6. So our final answer would be negative 6 sine of 6x. So an example that tends to trip people up right off the bat is something like this. It's really not that tricky, but I understand why people get confused. So if we had sine squared of x, okay, so obviously this isn't just sine of x, so there is no typical differentiation rule for this. So what you have to understand is that sine squared of x behaves the same way that sine of x squared does. And this is what we did at the beginning of the video, our first example. So whenever you see a trigonomic function that has some sort of exponent, sine squared, sine cubed, whatever, you treat it this way. The outside would be that exponent. So we bring down the 2, keeping the inside the same, which is sine, then multiply by the derivative of the inside, which is cosine of x. All right, so now that you know how to perform chain rule, I'm going to delve into what I call nested chain rules. Now, what I mean by that is that you can have problems with multiple levels of chain rule required. Let's take sine cubed of 5x squared, for example. Okay. So again, we're going to give our exponent on the trigonomic function our priority. So we'll treat this as we would sine of 5x squared cubed. Okay. So we're going to bring down that 3, keeping the inside the same. So outside. It would now become squared by power rule. And now we multiply by the derivative of the inside. So then we have cosine of 5x squared. Then, oops, we have one more thing that doesn't fall under our typical differentiation rules, and that is our 5x squared. So then we have to multiply by the derivative of this inside, which would be 10x. So your final answer would end up 30x sine squared of 5x squared times cosine of 5x squared. Now, I'm going to be giving some example problems, and I encourage you, having watched this video, to go ahead and pause the video before I start a problem and give it an attempt yourself. All right. So for the first problem, we're going to start with 3x plus 7 to the 10th power. Now go ahead and stop the video now and attempt it yourself. All right. So the way we'd start this derivative is by doing our outside, so bringing down our 10 and following power rule, and then multiplying by the derivative of the inside, which would be 3. So then our final answer is 30 times 3x plus 7 to the 9th power. Now cosine cubed of x. Go ahead and stop the video now. Alright, so the derivative of this, once again, treat this exponent as if it is the outside function. So we're going to bring down that 3. It's going to stay cosine squared of x now. And then multiply by the derivative of cosine, which would be the inside. So negative sine of x. So our final answer is negative 3 cosine squared of x sine of x. Next, we have the natural log of e to the x squared. Pause the video now. Now, if you know a lot about natural logs and exponentials, you would see that the natural log cancels out the e, and we'd just end up with x squared. But for the sake of practicing chain rule, I urge you to just take the derivative of the problem as is without simplifying it any beforehand. So we're going to do the outside, which will be our 1 over e to the x squared multiplied by the derivative of the inside, which would be e to the x squared multiplied by the derivative of our inside. If it was e to the x, we would have stopped there, but because we have something other than x, we're going to have to multiply by 2x. So then we'll have e to the x squared times 2x all over e to the x squared. Naturally, our e to the x squares can cancel, and we're left with 2x. And our last example, we have sine of e to the x. Stop the video now. All right, so to take this derivative, we're going to follow the same procedures. So the outside leaving the inside the same. So we'll have cosine of sine of e to the x multiplied by the derivative of the inside, which would then be cosine, keeping the inside the same, so e to the x, then multiply by the derivative of the inside, which is e to the x. And that would be our final example. Thank you for watching, and good luck.